this video, I'm going to introduce the normal distribution and its probability distribution function. Okay, so this is the probability distribution function. It's 1 over square root of 2 times pi times sigma, and then times e to the power of negative x minus mu squared divided by 2 times sigma squared. Right. So you might be looking at this and be like, oh no, that looks like a hard thing to compute. And actually, don't worry about it because we're not going to compute it in this course. But I just wanted to point out that this is what the probability distribution function looks like, so we can see a few things about it. First, let's see what variables are in this equation. Well, x, of course, that's our random variable, so that's okay. We can give it a particular value of x, and then we'll get a value of f. That's the point of a function, right? What else? There's pi. Pi is a mathematical constant. We know what it is. It's 3.4 approximately. 3.14 approximately. And then there's e. E is also a mathematical constant. But then there's sigma and mu. Okay? Now mu is the population mean, okay? And sigma is the population standard deviation. So remember, probability distribution functions are always for the population, right? So, so mu and sigma are from the population. They're the mean and standard deviation from the population. Right? If you were to give this function a bunch of different values of x, right, and plot the graph, this is what the graph would look like, this standard bell-shaped graph that we're used to looking at. So that's what this function is. If you were to give it a bunch of different values of x, it would produce this nice bell-shaped graph. Now, this bell-shaped graph, though, the shape of it will be completely dependent on how you define mu and sigma. Okay, so there's two unknown parameters in this function, mu and sigma, and depending on what values you assign mu and sigma, that can really change the way that this bell-shaped curve will look. Okay, so first mu is the center of the distribution, right? Remember, this is a symmetric distribution, and the mean, median, and mode are all right here in the center. Okay, and sigma has to do with the spread of the distribution, right? Okay, so let's go through a few different examples where we're thinking about different normal distribution curves. So say you have one normal distribution curve that looks like this, okay, and then you have another normal distribution curve that looks like this, okay. So both these normal distribution curves, I was trying at least to center them both on the same mu. Okay, so they both have the same mean. However, one of them has a much smaller standard deviation, much smaller spread. Now you see for the red curve, sigma is smaller, right? The spread is smaller than sigma of the purple curve, right? So this is an example of two curves with the same mean, though different standard deviations. All right, let's do another example. Say you have two curves that look like this. Say the first curve looks like this, and the next, I'm going to use green this time. So say the next looks like this. All right, so these two curves have different means, right? Here's the mean of this green curve. The mean of the purple curve is back here, all right? So the mean of the purple curve is less than the mean of the green curve. However, the spread for both these curves, okay, if my drawing is good, then the spread, I was trying to make the spread to be approximately the same. So the spread of these distributions is the same. So this is an example of different means, though the same standard deviation. One more example. Okay, so say we have two curves that look like this. Say the first curve looks like this, and the second curve looks like this. Okay, So do these curves have the same mean? No, right? This mean is still, the green mean is still more than the purple mean. Now, do these curves have the same spread? Do they have the same variance? Again, no. The variance of the first curve appears to be very small compared to the variance of the green curve. So the variance of the purple curve is smaller than the variance of the green curve. Okay, so using this probability distribution function for the normal distribution, you can come up with lots of different bell-shaped curves, though their appearance will depend entirely on what you set mu and sigma to be in this function.